just as in building a house, after the foundation is poured, we then need to work on the structure. There are 3 sessions in this videotape which address this point. In session 4, we will look into layout and process improvement in order to establish the streamlined flow in the factory. In session 5, we will study different tools which function as a nervous system in the factory and allow us to quickly respond when something starts to go wrong. In session 6, we will address the necessary skills for problem solving, especially in the areas of quality and machine maintenance. One of the most important concepts to learn for making a factory competitive is flow production. Here, flow refers to the movement of material through the plant. It assumes that material will not be stagnant at any point in time from the receiving of raw material to the shipping of finished goods. The benefits of flow production are early detection of problems, quick delivery of products to customers, lower inventories, flexibility to respond to customer demands quickly, and a more organized workplace. Contrasting to this, we may have disturbed flow in our factory, making the situation almost uncontrollable in some cases. Materials may be accumulated as excessive inventories, or we can't produce product because of a shortage of parts. In order to achieve production flow, however, there is also a long list of hurdles to clear. Even though the list of hurdles is long, it's important for each of us to believe that there is always a way to progress further. Instead of thinking of these hurdles as insurmountable obstacles, we need to think positively in terms of flow production being possible. Parts can come on time. Machines can run as required. We can produce quality products. And we can solve problems as they arise. In other words, man, machine, material, and method, the 4 major elements of production, are working together to achieve flow production. In discussing the many problems to overcome in developing flow production, let us first focus on layout. When describing layouts, there are 2 major types. A process-oriented layout is one where machines are located according to their function, whereas a product-oriented layout is one where machines are laid out according to the flow of materials. Not surprisingly, a product-oriented layout is much more suitable for achieving flow production. As we develop the product-oriented layout to achieve flow production, the material transfer between different processes becomes much easier. Also, production lead times and inventories accumulated between the processes will be reduced significantly. Take the case of Fireplace Manufacturers Incorporated. You can see the change in material flow. Before, the flow was very complex. Now there are 4 major flows, one for fireplaces, one for glass doors, one for pipes, and one for accessories. Each is dedicated by product line, more like a factory within a factory. Because of its product focus, this is sometimes referred to as a focus factory arrangement. Now, raw materials are delivered to the point of use, and material flow is greatly simplified. The new layout is easier to manage, and the benefits achieved were substantial.
It seems like what you have just explained to me was simply to tie different operations together based on the material flow. Am I right?
Yes.
Well then, what's so difficult about doing it? It seems so natural.
You're right, but often we put the same type of machines together rather than think about the flow of material. Also, we may simply put machines where there is open space. We may even put or buy the wrong kind of machines.
What do you mean by that?
See this example. You'll see it is difficult to streamline the flow in the case on the left. But if you can dedicate the machine to the material flow, as you see on the right, it is easy to develop a streamlined flow.
Well, that means we'll have to have more machines.
Yes, but more compact or smaller machines.
But still, that may be expensive.
Possibly, but you should be able to utilize people better, keep inventory lower, and shorten production lead times, and increase the quality levels, because this is easier to manage.
I see. So we have to look at the total picture. Is that what you're saying?
Yes. Let's take a look at a few examples here.
We used to run lot sizes of about 500 pieces of each casting through each individual machine. And they would start up running through one of the amirs up in this area. We would then send them down to do all the drilling and the tapping, which was an area down in the drill room, which was the other end of the shop. And after that, they would go through a cleaning process, come through inspection, and then end up going into the warehouse. And following the warehouse, they'd be pulled out whenever they needed to go into assembly. Now, to give you some statistics as to how long all this used to take was, for average lot size of 500 pieces, used to take anywhere between 10 and 15 days to go through the whole shop. From a quality point of view, we used to have rejection percentages up around about 20% for each item. From a cost point of view, if I relate costs to just direct labor right now, this part used to take us about 7 minutes to produce. This part used to take us about 5 minutes to produce. Now that we've set up the cell, what we've done is we've brought all the machines that are involved in the process into one area. So we have the turning process, the drilling and tapping process. All the machines are compressed together, and we have one operator operating the whole cell. Now the effect of this is that, first of all, we've reduced down all the travel time throughout the whole shop. We can get one part flowing through each machine, going from start to finish in a very, very short time. And in fact, what we've done to the lead time is that we compressed the lead time from our 10 to 15 days down to, in effect, 3 minutes.
In addition to the lead time, reject rate went down from 20% to 2%, and the operator's work time per part was cut in half. Plus, since a part goes through the whole cell in only 3 minutes, there is no need for a computer system to track it. Production control is now in the hands of the operator. In this example, 4 operations were previously run independently of each other. When all 4 operations were combined, the carts full of inventories going between these operations were eliminated. This arrangement also pointed out which operations needed further improvement. For example, there is still sizable inventory buildup between each operation. The parts are not yet moving through like a stream, indicating further improvement potential, not a problem or an impasse. Also, in the future, these 4 operations may be tied to the assembly line, thus furthering the integration of material flow. This is an example of semiconductor fabrication. The need for this third clean room was eliminated by simply rearranging the machines, integrating the 3 rooms into 2, thus helping smooth material flow.
The results have been quite dramatic. The racks are empty, the material is moving, the amount of material we needed in the line has been reduced by a factor of 2. This reduction has allowed us to increase our capacity to have an empty room, a room where we could bring in new equipment for other new things that we want to do in our technology.
This example will illustrate the benefits of a product-oriented layout. First, this represents the typical process-oriented layout. Here, completing the first batch of 5 units takes a fair amount of time. Our next example represents the product-oriented layout. Now, to complete the same batch of 5 units takes much less time, and work in process is substantially reduced when compared to the previous layout. This is the ideal. When this is accomplished, this is called one-piece flow production. The U-shaped line, or U-shaped cell as it may be called, has unique features which help to achieve this one-piece flow production. A U-shaped line can achieve improved communication within the U-shaped line, simpler flow and easier production control, ease in combining work steps, more flexibility for changing production volume simply by changing the number of people in the line, and better teamwork between and increased ownership for operators, in achieving common goals. Now, let's hear from some people who were involved in converting to these new layouts.
In our old production layout, you can see we were organized along production process cells. We had a sub-assembly area feeding into a higher level of assembly, feeding into a higher level of assembly, and so on until the product made it through the production process. In this chart, you can see the black dots representing people and how they were placed. And there were a great many barriers to the movement of materials and the communications just because of the layout. You can also see the production process with these green arrows as being fairly awkward and not as smooth as it could have been. To contrast that, we can look at our current layout. In this case, what you see is we've eliminated roughly 25% of our production operation floor space and introduced U-shaped production lines that are responsible to do the complete assembly. You can see the black dots again representing people on the production line, and the production flow has been greatly streamlined. The barriers to production that existed in the old layout no longer exist. There's a great deal of openness in the work cells. Information is easily gathered and shared amongst individuals. The feedback of problems from the person at the end of the line to the beginning of the line, if there is a problem, is very fast. And also, there's a great deal of personal identification that happens within this team of people. They're able to recognize the goal at the end being a common goal, and they can share and help each other a great deal.
Where we've come from is quite an improvement. In the old days, we still managed to produce the units, but we always had the traditional end-of-the-month crunch, where we were scheduled to produce a certain number of units, and at the end of the month we had produced them, but it was in the last 3 days of the month. And we had a lot of confusion on the line, to be honest. As I stated before, product flow wasn't quite organized. People were building to standard, yet they were not being consumed that way. And what we've got now is a very precise movement, and it eliminates the end-of-the-month crunch specifically. It's created very linear flow throughout the organization on through shipping, which in turn helps support the customer, or does support the customer.
Our very first cell we produced was a cell that produced these little four-way valves for Newcon, and for 13 years the very best time we could assemble these in was 7 minutes. After our first cell was developed, we produced this valve in 3.5 minutes, which cut that assembly time in half. Not only do you save time and energy in building the product, but you end up with a better product. You end up with a product that's brand new, that hasn't been in inventory, and is to the latest drawing. It's important to remember that a cell is never finished. You can get it to a certain point, but there's always times for improvement. And most of those improvements are going to come through the people who are working the cell. They realize where their wasted moments are, where their movements are going, and they realize they can tell you just little ideas like we need a tool here, or we need to move this bench a little bit to the left. And it should pay real close attention when developing cells is to the fine points of where the product should be set down, or little movements that you're doing that you feel are wasted.
We thought that it would be very good to start with a simple part. This is an idler gear that goes in our 5-speed transmission. The cell that we worked on is simply a cell that hobs these teeth, and then we do the tooth pointing in another operation, and then we do a finishing operation. Here's how this cell was laid out originally. This was typical, the inline kind of processing that we've had for many, many years here at BorgWarner. And it's what we've done, the plant layout, everywhere there was inventory, we've colored that in red. The incoming stock came in here in tote boxes, big 4-foot cube boxes. There was an operator stationed here that did the hobbing operation, and then he stored them on we call these lazy Susans. They're about 4 feet in diameter with several layers, so you could put a lot of parts on those. Then there was another operator stationed here that did the tooth pointing operation that I mentioned. And then again, That operator stored them on another Lazy Susan. The last cell then consisted of 2 of these shaving machines, and then we filled this conveyor full of conveyor racks and finally washed the parts and put them in another cargo container where they went to heat treat. Our U-shape concept was taking all that same equipment and arranging it in a U-shaped line. Here we're showing the incoming stock right here, and an operator picks a part up and he hobs it, chamfers it, does a deburring operation, which was down here, and then shaves it, washes it, and puts it in an outgoing tote box. So you can see readily we had 3 operators working here, and we were able to run this cell with 2 operators, and they sort of chased each other around that cell in a merry-go-round fashion.
By spending a few $1,000s to change the machine locations, more than $100,000 a year was saved with productivity improvements.
This is the complete gear cutting department for our T5 transmission. And you can see that these were all progressive lines, lots of roller conveyor, and lots of these infamous Lazy Susans. And wherever you see those round circles or these long spans of conveyor, that was inventory. So after we've gone through this department and completed our JIT, this is what it looks like. And you can see all the floor space that's been freed up for other product. And you see no conveyors or Lazy Susans. The lines are in JIT form, U-shaped, and we're very proud of what we've accomplished. But the key thing I think we learned in doing this is when we made the first U-shaped line that I described in detail, we did that without any operator involvement. It was just a matter of the industrial engineers went out there and over the weekend we rearranged the equipment, and when the people came in on Monday morning, here was a new operation for them to run. So there was a lot of resentment naturally from that.
So I think many times the engineers need to talk to us a little bit more about how we work, and then how they can plan the area better with their ideas and our ideas so that we can work together. It's just like, say, if I were going to go to your desk and rearrange all the papers on your desk or put the telephone down on the floor. It's just like someone coming in and doing that. So I really believe that we can work better with the engineers and other planners if we would get together as in a team.
So we went through a lot of pain and suffering in getting that cycle back up to speed. So in the second cell that we arranged, we corrected that problem. We got all the people in a room, showed them what we intended to do, gave them a copy of the plant layout, and asked them if they wanted to change the layout, what would they recommend? Well, as it turned out, they didn't recommend anything, but the smoothness of the startup of that was the difference of day and night. So any other cells that we've done have been done with total operator involvement, and that's the key to making this thing work. People are anxious to correct those deadly wastes of bad quality, lots of inventory, and not utilizing their skills, but trying to utilize a machine. So I guess if there was any recommendation I would make, it's to get operators involved if you're going to attain this kind of success.
The key point is that in order to achieve the full benefits of a U-shaped line, we need to involve operators and enhance our overall skills.
The reason why I think it's a very good job and I think it's a good cycle is because we take a raw piece of stock and we run it from beginning to end. And while we're in the process, we're able to make any adjustments or any alterations that are necessary. Okay, whereas before, maybe they may have one person doing the semi-finished cut and then sliding it on down the line, okay, and maybe they wouldn't be able to catch anything that is wrong. I feel like with the JIT cycle and the way it's set up, we'll be able to catch anything that goes wrong.
Since there is less inventory on the line, with more value-added work for the operator to do, the U-shaped line arrangement requires that operators develop a new set of skills. These skills include understanding a wider scope of their work, working on a broader range of machines or procedures, working as a team instead of as individuals, addressing problems quickly as they arise, and gaining ownership of running the line without much supervision. Industrial engineers are not the only ones who can develop layouts. In this case, an operator developed a U-shaped assembly line with the flow production concept, where operators complete the assembly from start to finish. This resulted in a major reduction of inventory, floor space, and production lead time. This is an example of a line developed by Sei's apparel division in Japan. In this example, there are 8 operators running 23 machines to produce one product. This line has 7 machines, but there are just 2 operators. Each operator handles 3 machines, and sometimes more. Called multi-machine handling, this is a very common practice in Japan. In a conventional line, one operator is responsible for tending one machine. As a result, in-process inventory tends to pile up as machine speed increases and quality becomes more inconsistent. But in the line shown, the machines may be running slower than typical machine speeds, which is fine, as long as they meet the customer's need and have finished sewing the material prior to the operator's pick time. That is, the time from when the work is ready to when the operator returns from performing another task. In such situations, compact, unsophisticated, and relatively inexpensive machines are desirable, as they can often deliver high quality with fewer problems. Machines are modified for simplicity's sake, so that even a new employee can be put right into the line. Because the machines are so easy to handle, operator training on each machine is extremely quick. Thus, each operator quickly becomes multifunctional. In an integrated line such as this, any interruption, even as minor as changing a thread bobbin, will cause imbalances. To minimize this, a mutual help zone is provided, allowing the work to be passed on, sort of like the takeover zone in a relay race. This evens out the work performed by the operators and ensures smooth production flow. This operator at the Japanese automobile manufacturer, Kanto Auto Works, is practicing one-piece flow production. The machines are laid out to accommodate this flow, allowing 2 different parts to be produced on this line. As this layout shows, the operator does 15 setups for one part and 10 steps for the other, for a total of 25 steps to complete the cycle. A good example of multi-process handling. In this arrangement, there are 4 operators, each following the other. Because of this practice, as the market demands change, the number of operators can be changed accordingly. Notice the high level of housekeeping and workplace organization shown here. Notice also the simple mechanism used to eject the part, as well as the automatic parts transfer system. Not sophisticated or expensive, but they work. So the benefits of this type of layout include increased productivity, increased flexibility to changes in market demands, increased quality, and increased operator morale. Again, however, people are the key to making this type of arrangement a real success. Only when we begin to understand the potential of these techniques and the importance of people involvement in implementing them will we be able to figure out how to use the freed up labor time. The point being that our organization should allow its people to grow, to acquire more skills, and to share in the benefits through secure employment. Without the involvement of the people, we will never be able to achieve continuous improvement.
I think I understand the potential of these improvements, but can you show me an example of this improvement process?
Okay, here's an example. This is a company that makes automotive switches. This layout was developed before the change. As you can see, the material flow was very complex.
Wow.
Now, this is the new layout. It is U-shaped, very simple flow.
Oh, it's amazing.
The result was reduction of inventory, labor saving, less confusion of work, and total time to process this material was reduced from 3 days to 17 minutes.
Wait a minute, it was reduced from 3 days to 17 minutes?
Right. In fact, after the change was successfully completed, they celebrated with colorful balloons.
That is wonderful. But are the benefits always this impressive?
Generally speaking, you may be able to increase the productivity by 30 to 40% and reduce floor space also by 30 to, I would say, 40% or sometimes 50%, and significantly reduce the inventory while making major improvements in production lead time, often again from days or weeks to even minutes.
These are major improvements. But what about people? I mean, those who are removed from their previous job.
This is a very critical question. What I have found most effective, though, is when there is excessive labor, remove the ones with the most skills. Have him or her do more advanced jobs. This in turn should generate more business for the company. And no layoffs should result from improvement activities. If a company lays off people because of their improvement activities, I don't think such a company can continue improvement for a very long time.
What about machine breakdown? If any machine goes down, we're going to be in big trouble, right?
Yes, but you should improve the maintenance activity too. That's how we can move forward.
It sounds like there are a lot of changes associated with this type of improvement.
Yes, but by focusing your efforts and carefully planning the move, you'll be able to gain confidence as you go and share the benefit with all involved.
I understand.
At Puritan Bennett, this is what they recommend to those not yet utilizing these techniques.
Take the time. We were as skeptical as all other organizations when we first started, but it seems that once you start with the just-in-time approach, that just catapults. You make one improvement after the next, and pretty soon you've got a major improvement that you really see in both time and labor. And morale. You know, the morale is really boosted. You take a group of people and you put them together, and once you've got them to work together as a team, you've got a tremendous asset to your company.